Cool. Yeah, pleasure to be here, and I'm going to speak about our little TicTacToe app that we created with Reason and React. And when I say we, I really mean most of us, because this was a team effort in the last two sort of hack-togethers of the Reason group in Vienna. We got pretty far, where we had sort of a working application, but then I couldn't resist and took it a little further at home. And so the idea is to talk about that from the very beginning down to some of the details. So it's kind of a deep dive into this application, to take the analogy from before, where we're all divers. But it's really a beginner's deep dive. So I'm certainly a beginner in Reason, and I hope at least some of you are too, because this is not going to cover any deep stuff of the language. Try to keep it very basic. So yeah, it can be quite interactive. So I'm going to start with some general stuff, but then I'm going to show a lot of code. So if you want to interrupt and ask questions at any time, that's perfect. But before we jump into it, let's take a look at what we actually want to build here. So this is the final stuff, as cool as it gets. A little TicTacToe app where you have this 3x3 board, and you can click, and then it's the next player's turn, and they make a circle, and then it's cross again, circle, cross, and in the end, someone might have won or not. So if we restart and try again, oh wait. Okay, well, there's a tie. The board is full. No one has three in a row or a column or a diagonal. So yeah, that's it. And I mean, I could play this all day long, and I certainly have. But let's also take a look at the thing behind this. What do you have to do to get going? The easiest thing is probably to start with some boilerplate. In our hack together, we started with the Reason React example from GitHub. The only slight downside to that is maybe that it has multiple applications in the same repo. So if you only want to work on one application, then you either have to ignore the rest or strip it out before you get going. Or, of course, you could start with Reason React TicTacToe, where I already did that. So kind of a nice recursion. If you want to build the next TicTacToe, start with TicTacToe. And then what's going on there is not too much magic, actually. In the package JSON, you define your dependencies as usual. So there's React, React DOM, and then this new thing called Reason React. And then there's one interesting thing in the dev dependencies that's called BS platform, the buckle script platform, and that's basically where all the magic happens. This includes your sort of Reason compiler and everything you need to get going. These boilerplates also include scripts in the package that are already defined to, on the one hand, run buckle script, which takes your Reason code and produces plain JavaScript. It might go through OCaml in the intermediate, but that doesn't really matter. And then they also have a separate task to run Webpack. The only job of Webpack here is to bundle several JavaScript files into one JavaScript bundle that you can serve to the browser. There's nothing specific to Webpack here, really. And there's also a file called bsconfig that's also responsible for a little part of the magic. It has these BS dependencies that basically tells buckle script or Reason how to link or how to get from things that you write in Reason to corresponding node modules that you installed via npm. So we'll see how we address Reason React in our Reason code. but the way we installed it is just through npm, and the reason this works is because we declared it in the BS dependencies, basically. All right, so that's sort of the general setup and some of the magic that happens behind the scenes. How does our own app look like? It's quite simple, actually. There is one indexed HTML file, which is just a simple static HTML file that references the bundle that's generated by Webpack. So, you know, we don't do anything fancy here with Webpack, where we might generate that HTML through Webpack, and you know, where we might want to add hashes to URLs for the bundle and so on. We leave all that part out, and we just have a static file that assumes that this bundle is already generated and at this particular location. And then what's happening is, so we use Webpack, so there's some entry point, and we define that entry point already in Reason. So there's a file entry.re. But all it really does is rendering one component, a React component called TicTacToe, and that's our main application component. That's also responsible for managing the state in our app. And then we have one more component called board, and that's sort of a dumb component that's only responsible for rendering the board given certain props, and then it installs event handlers and propagates these events upstream back to the app component. And one more thing we have is kind of interesting, is we create this file game.re, which is just responsible for defining certain types. And so this is, so it gives sort of a nice overview of the domain model of the application. All right, so that's just a little overview, and we'll dive into it right away anyway. So I've started to use Visual Studio Code for this, and I have to say I'm quite happy with that. Here we already have this index file, and as you can see, there's not much going on here. There's a head, there's a body, and it has a section where our React component will go, and then it references this script. That's defined here. Oh, and all it does is it calls a function in this package or module called React DOM reason to render an element into an HTML node with a given class name. Oh yeah, see. Okay. Right. So that's the entry point. And then in our Webpack configuration, we basically say we want to produce a bundle, and the file that's responsible for that is this entry file, but already the sort of compiled version of this reason file, which ends up in this folder, and it's a JavaScript file, of course. Yeah, so, but before we jump into TicTacToe, maybe let's take a look at the game file, because this is also how we actually started coding, at least after recommendation by Patrick, and I think that was a very good way to approach this. To first sit down and think about what's actually our domain model, what are the things that we'll encounter in this application, and then we start to type them. There we can also already see some nice aspects of Reason. So the first thing we'll want to have in our application is, of course, players. There are two players. One sets crosses, the other sets circles, and so we'll just define that as the two variants. And this is actually called the variant in Reason. You can also call them constructors, or maybe you might think of them as enums. The only thing that's special here is that they have to start with an uppercase letter. And as soon as you have that, Reason knows that's you sort of made up that name, and anywhere you mention it, it will recognize it as part of this, so to say, enum. So this is simple. We just have two alternatives. This gets a little more interesting. We also want to keep track of the current state of the game. So we can be currently playing, but the game might have already ended as well. And then either one of the players has won or there's a tie. And one way to represent this is, well, we can also we can have a tie constant here. But in the one case, what we do is we have this tag 1, but then in addition, whenever we write 1, we'll also say which player won. So in other code, I will then say 1 cross, for instance, and that's the value. I could have written this differently and say 1 cross and 1 circle, sort of make the distinction explicit and use 2 separate constants here. But we'll see that in some cases it's going to be nice to be able to get back from the game state type directly to the player type, or sort of extracting this out again. Sort of like normalization of the data. We do something similar for the field type, where we want to distinguish what's currently set on a field on the board. And this can either be empty or there can be something on that field. And again, we could say explicitly there's a cross or there's a circle there. But what we did is we again used this parameterized constructor where we say it's filled, and then the parameter is again which player type set or filled this field. Right. And then we just compose the whole board out of fields. So a row is made up of 3 fields. And then we also define this board type, which is just a tuple of 3 rows. We had some debate about whether that's really necessary. I mean, it just saves a few keystrokes here and there. Maybe you could also just always deal with 3 rows basically. But yeah, that's what we did. There was also some interesting discussion in the beginning about should we assume a constant size of the board, or should we always make it 3 by 3? I think that was a very interesting question to ask yourself, because initially my gut reaction might have been let's keep it general and let's support n by m or at least n by n fields or boards. But it turns out that it's really nice to restrict yourself here, because I mean, let's be honest, there'll probably never be a different TicTacToe other than 3 by 3. And if we keep it general in the code, there's just so many edge cases that we have to deal with all the time, because Reason won't even let us not catch an error. And so if you keep it as a general array of arbitrary dimension, that you'll always have to check are we out of bounds when we address the array and so on. And so this restriction to 3 by 3 gives us the complete safety that we're not screwing up in any place of the code and address a field that doesn't exist, while at the same time not really making things more complicated. In contrast, it just makes things easier. So yeah, that's that. And then following from that, we'll also have 2 types to sort of address fields on the board. So since these are not arrays but just tuples, we can't say given a row, give me the first element. I can't really use integers to address things in these tuples. But instead, we just make up our own address space, so to say. So we say a row is addressed by one of these tags, and a column can be C1, C2, C3. We'll see later how that's really used in the code. So yeah, that's basically our domain model. And the nice thing is from this from these type definitions, you can already get an idea of what's going on in the application. And some of the things just follow logically from these definitions, which of course makes it even more important to think hard about this and not skip that step too quickly. So let's take a look. As we've seen in our entry file, we just rendered a TicTacToe component, and the way this looks like is basically we open the game, which is doesn't really mean that we start the game here, but what this is doing is it imports everything that we defined here in this module into the TicTacToe module without having to add an explicit namespace to everywhere where we use this. So down here, I can just say board type without having to type game.boardType. If I skip that open statement up here, that's what I would have to do, and that would still work, but it's just a little more convenient this way. Let's skip the glamour part for now, and then what we have here is basically a module where we define all kinds of things that make up our React component, and in the end, we say React.create component from this module that we defined here. And what's happening is basically that React.re is taking these definitions that we make inside here. Let's say the name of the component and the props and the state and so on, and most importantly the render function, and it's creating some other functions out of that, and it includes them into this top level namespace of our module. So this sort of module is just internal that's just an implementation detail basically. What matters in the end is what this thing produces and then puts into the namespace of the whole TicTacToe module that's really the file. So that's sort of a little weirdness of this API in its current form, but I guess that will change anyway. In the end, you also have to declare this create element function, which is what really matters from the outside. So whenever Reason sees JSX syntax, it looks for a corresponding module that has a create element function. And that's why you have to declare it here, depending on what props your component expects. But that's really just a bunch of boilerplate that you have to get used to. What's interesting is, of course, the usual React stuff. So we've already seen the name. The props in this case are just the so-called unit type, which means basically nothing, or in JavaScript you might think of an empty object. Because this component doesn't take any props, of course, but it does have state. And we have to declare that here, where we say we want to keep track of the state of the board. What values do the fields have. We need to keep track of whose player is currently active, whose turn is it. And another thing we did here, or at least I did here, was to keep track of the game state. Now, to be honest, one could probably write this a bit differently, because you could probably use this just from the board every time you need it. But yeah, basically what we do is just whenever the board changes, we also update the game state if necessary. Right. The initial state is just an empty board. It's really convenient to write. It's just a tuple of 3 empties, and then 3 times that tuple makes a 3x3 field. The starting player should be the cross, and the game state in the beginning is, of course, playing. Makes perfect sense. I'm going to skip through the rest for now, because what you always want to look at with a React component is, of course, the render function at the bottom. And there's not too much going on here, except for some styling maybe. So we have this container as a div, and then we also render this GitHub ribbon, not too important. But the really interesting thing is when we render the board, of course. So we pass in the current board so that the board component knows where to put crosses and circles. We also pass in a game state, and we pass in a function, a callback function, that will react to clicks on the board. And I'm going to come back to that later, maybe. Other than that, there's just this paragraph that tells us who has won, if anyone, and also the button where I can restart the game if it has ended. Some interesting things that we see here is maybe this switch statement. Probably very familiar. We basically pass in a variable, and then we have to cover all the cases that this variable might take on. And that's kind of a good thing about Reason here, is that it really forces us to check all the cases. There's no implicit fall through or default case. We really have to react to everything.
You can make a default case.
You can make it yourself, right? Which we actually see down here. So all we care about here is the game, is it still playing? Then we don't render any button. But in any other state, no matter if it's won or a tie, we render this restart button. There's nothing too magical about the underscore. I could also write a variable name here, basically, and then I could access that in this code over on the right-hand side. But then Reason, or in this case Berlin, will warn me that I didn't use the variable. And if I use an underscore, that's a signal to the language that, you know, it's a placeholder, but I'm not going to actually use it. Right. Another thing we see here is that we have to deal in a somewhat special way with just plain text elements. In the JavaScript version of React, you can just put content into your div or span container. You can just write it as plain text here, and React will translate that into a text node in HTML. But here we have to be explicit and call string to element to turn that into a text node. And also, if we want to render nothing, we have to use this explicit null element. And, you know, there isn't even really a null in Reason, but it wouldn't work anyway. Right. So that's sort of the outline of the application component. Let's take a quick look at the board. So this is the other way around now. This doesn't have any state, but it does have props. So we get the board, and we get the game state, and we get this handle click function. And here we see how we use these ID types. So when the user clicks somewhere, the outside world, of course, wants to know which field was clicked. Was, you know, the field that coordinates 1, 1 or 2, 2 or whatever. And these IDs are our way of representing that in the end. Right. So when this renders, what's happening is basically that we return a div. It will have some special styling so that it will be a table. And you know, we do something with the cursor and so on, but that's not too important. What's happening inside is that we just render the rows. And there's another function in here that is responsible for that. But what we also see here is this concept called currying. So basically what's happening is that render row expects the props as they were passed to the whole component, and then also the ID of the row and the actual row, which is a tuple of 3 fields. Now the thing is, I could, down here, I could write render row props, and that would work just fine, right? But the problem is I would have to repeat that all the time here. And it's not too bad here, but in general that's probably something you want to avoid, and it can be avoided very conveniently by just declaring once that we'll construct a function render row underscore that is just render row with the props always passed in as the first argument. So reason knows that this function expects 3 arguments as a whole, and if I only pass in 1 here, it doesn't actually execute the function yet, but it just creates a curried version of render row. Right, and then the underscore here, that's just my sort of little naming convention. You could call this render row with props or something, but that sort of defeats the purpose of saving keystrokes here. And it also, I think it's quite nice to read. Right, so then in render row, it just goes on, a similar thing. Each row is just rendered as a set of its field. So again, we have a div that's a table row, and then we render each field with a render field function. Maybe I should also point out that this is also a bit different from the concept of components in JavaScript React, in that these are just pure functions. They're not methods of a component class or anything, right? I could write this function anywhere, because it would still just get the props and do its thing. And the only way they're sort of coupled together is in this module for this component, but even that doesn't really matter ultimately. Right, so we had render row, which calls render field. Here again, we make use of currying. So every time we call this function, we're going to pass in the props and now also the row ID, because that's going to be the same for every field in this one row. We also pass through, so you know, both here and here, we pass in the value of the row or field and also its ID. So that in the end, in render field, we basically get the props, and we immediately destructure them. So you might be familiar with that from JavaScript. In this case, it's sort of like object destructuring, where we extract the game state and the handle click callback from the props. And then we also get the row ID, the column ID, and now we're down to 1 field, so we get 1 field type, which is the current value of the field. What you can see here is that we also typed some of the parameters of the functions. So instead of this, I could have just written RID. And as a matter of fact, that's what I did down here, right? For render row, for instance, I did bother typing this. But if you want, you can always be more explicit and not let reason figure out the types for you. And the way to do that is to put them in parentheses and with a colon. One advantage of that is, and that's actually why we did this at some point during working on this, is it gives you nicer error messages. So, you know, if at some point there's some error in your application and reason is complaining, you know, you're passing some you're using this parameter in some way that doesn't really work, or you might get some really obscure error message, then this is a way to sort of isolate the error. And you'll know, am I passing in the correct thing that I'm thinking I'm passing in, or you know, is something going wrong on the outside? You basically split the problem in 2 halves. Is the error outside of the call of this function, or is it inside of the implementation of the function? Right. So then what's happening here is just some rather boring styling stuff. So we want to set a different cursor. If we're still playing, then it's going to be a pointer. Otherwise, the default cursor. We'll also switch the background colors based on the game state. So the default sort of playing or tie is that there's no background, right? briefly forgot what I was talking about, but what we're talking about is basically this green background here, right? So as long as we're playing, the cells have no background at all. But as soon as somebody has won, we want to distinguish between the fields of that player who has won and all the other fields. And here we can see this nice little extraction from this variant type with its parameters to the actual player. So first of all, here we extract the player from this one structure. And if that's the case, then we also, then we construct a corresponding field type for that player. So right, so we have the player, which is either cross or circle, and based on that, we want to compare to the current field, is it filled with that player's value? So is it filled with cross or circle? And if that's the case, so if it's filled with the player who has won, then the background is light green, otherwise nothing.
I have a question.
Yep.
Nothing is what? Where does this come from?
Oh, excellent question. Yeah, that's part of my little glamour binding. Basically,
because like all the statements of the switch needs to be the same type, kind of, or like the same.
right? Mm-hmm. Mm-hmm. So let's take. Wait. So we had. Oh, it's opening it here. Interesting. Wait. Oh, I know what's going on. So yeah, this is sort of the glamour binding, and so a CSS declaration is either nothing or it's a property where you have the property name and the value, or you can also use selectors. So that's where this is coming from. Wait. Where is my? There it is. Okay. So here we have the two nothings, or in this case we call background, and that's just another function in this glamour binding, which will produce something like this. That's just a shortcut. But in the end, as you say, it has to be all the same type, and in this case, it's basically a CSS declaration. Right. Then we construct some CSS out of that. Maybe I'll talk about that a bit later. And in the end, we construct a span that has, the table cell style, and we fill it with some text. So either it's the empty string or a space basically, or a cross or a circle. And what we're doing here is we're constructing a Unicode string. It's a little cumbersome, unfortunately, in Reason. It seems it doesn't, or OCaml doesn't support Unicode strings natively, if that's a fair statement. It basically treats them like a bag of bytes, or every string. But in BuckleScript, there is a workaround for that, where this will just get translated into a plain JavaScript string, where this will just work. So this is just a Unicode symbol for a cross and a circle.
What if I assign such a thing to a variable? What kind of type has it then?
Good question. I haven't tried, I think. Will it tell us? So maybe it just assumes that everything's a Unicode, a UTF-8 encoded string in the end or something.
Interesting, yeah.
Assumptions. Yeah, but in the end it has to be a string, right?
Yeah,
It's just an implementation that there is a Unicode.
But I mean, the question is, if this is just a string in OCaml, how does it translate from these byte strings to JavaScript strings? It has to make some assumption about what their encoding is.
To JavaScript it's easy because a string is a string, and if you have Unicode in JavaScript, then you just support, and you have that, then you just support that, right? But if you have that in native code, okay, you can't have that statement in native anyway. So.
But that's basically what I'm wondering is if in native code you, and I don't even know how to do that, but you know, if you did something where you're using some byte value here, right? How does that get mapped into JavaScript?
Yeah, it would be interesting if it takes the whole, like every character of this declaration there and just makes a \u whatever for each character. That would be interesting actually to see in a lib.js file, which it generates, like in your program, lib JavaScript, and you can see it. So this is like the compiled output of AccuScript.
So I'm gonna look at board. This is interesting.
It's also pretty clearly defined, I think, on the AccuScript website. There is some tables and stuff. What type maps to what? From OCaml to JavaScript and stuff. I don't know if that's there, but I'm just saying you have to be aware of that, anyways.
Yeah.
This is the stuff. Right.
So it doesn't do anything actually. It doesn't do any UU mapping or whatever.
I mean, I think that's fine as long as you're just running it in JavaScript.
Yeah. And I mean, you can't have this special AccuScript declaration anyway in a code that you compile to native, right? Because that would be invalid.
Yeah.
But as far as I know, OCaml does support Unicode by default. Only like the recent parser which makes some trouble with Unicode.
Okay.
Need to verify that though. Just
Right.
sorry to interrupt you.
No, that was a good question. Yeah, and then at this point we basically rendered the board, right? The interesting question is now what happens when things actually change, when the user clicks somewhere. And for this we have a regular onClick handler on the span, and this is the usual stuff. It's a function that gets an event, which we just ignore here, and then we call handleClick, which we got from the props. And fortunately we also passed through the row ID and column ID, you know, whenever we called render field and render row and so on. So we can just pass that through to handleClick now. And at this point, we basically go back to the application component and see how we defined handleClick here. And this is a bit interesting because we have this function playTurn defined here. But we don't just pass that as the prop value, but we have this little updater. So what's that? We get the updater from this parameter that's passed to the render function. And this is called a component bag, which is kind of a very interesting concept. The idea is that this contains everything that you might be interested in when you deal with your component. Basically, sort of instead of the this pointer in JavaScript, right, where you always know what component you're currently dealing with, in this case, this is just a pure function, so it doesn't have any this. But instead, it gets this parameter. And among other things, it contains the state and this updater function, which is ultimately provided by the reason React bindings. And what it can do is basically turn a function that gets also the component bag and some other parameters into a function that can update the state. And the way it can do that is by returning something. So in playTurn, in the end, we can return the new state of the component, and this little wrapper updater makes sure that what our function returns becomes the new state of the component. Because basically there isn't really mutation here, there is no set state, so we have to do it this way. And I think it's actually a very nice way. It's sort of similar to Redux, right? Where you have your reducers that get the current state and some action, and they return the new state. Similarly here, we get the current state and some extra parameters that happen to be passed into our callback, and we return the new state. Right, if you want to take a look at what this actually does, it's kind of interesting. Just looking at the type definition can also sometimes be interesting, and can teach you something about the type system. So here we're basically saying this is the type for the updater function, and it depends on some arbitrary type, on some data that's passed to the handler in the end. That's up to the end user. So that's sort of a type parameter to whatever comes afterwards. But then we're basically saying it gets a function. Can I wrap this easily? For now, I'll just do this. So what this is basically doing, it takes a function, right? That's the first argument of the updater. And that function, in turn, gets a component bag, which is what we saw before. And that component bag, again, has to be parameterized based on the state, the props, and the instance vars. And then, so the function takes the component bag, and also, as a second argument, it gets the data that's passed to the function originally. And then it can return some state, but it's optional. So we can either return some state or nothing, which means that the state will not change. So it takes such a function that has basically two parameters and returns the state, and it turns it into another function, or at least that's one way to read this, that takes just the data and returns nothing. Now, there's always multiple ways to read this because of currying, basically, and in the end, there's only functions to take one argument, and you compose them. But if you sort of sum it up this way, then we can interpret this as a function that takes two arguments and returns this, and so on. Is that almost clear? Right.
You could explain currying now, but then we sit long here.
Right. Yeah, in a sense, we also curry here, right? We pass in play turn, but in the end, a function remains that still takes the data that we pass to it, which in this case is the row and column ID. Right. And then what's going on here, so that's maybe the biggest magic here. Other than that, we just look at the current game state. If we're still playing, then we're doing something. Otherwise, it doesn't matter where the user just clicked. We won't change the state, so we just return none. If we do want to change the state, then we basically have to compute a new board, player, and game state. And we have to wrap this with in this sum tag. So this is nothing too magical. It's the same principle that we used for our field types and the game state. It's just a sort of very common and built-in thing that you have these maybe types. Either they're something or they're nothing or none. But
is it actually the same? Is the maybe type just one of these union types? Yeah.
Well,
and it accepts basically so it's either unit or unit or sum, and then accepts.
None is not unit.
None or sum. Okay.
Yeah.
And then it accepts for sum, and it accepts everything, whatever you give it.
In general, yes, that's the maybe type. In this case, we have to return a valid state descriptor. Yeah. Right. So we compute these new things here, and this is kind of similar to the render functions in the board. We sort of traverse down the tree, or the rows and fields. So similar, we have a function that updates rows. And these functions, they always take a player and the current position, and then whatever is there on the board currently. And then they return the new thing. So update board, takes the board here and then returns the new board after the update. And the similar idea for update row. It takes a single row, which we immediately deconstruct into 3 fields. And then in the end, it returns a tuple for the 3 new fields, if they have been changed at all. So again, a lot of currying going on here. In the end, we end up in update field, which basically takes a player and a field value, and it has to return a new field value. This now turns out to be really simple, right? We have 2 cases, basically. If the field is empty now, we're going to fill it with the current player. If it's filled already, and it doesn't even matter with what player, it stays the same. Right. So then, all these functions return, and in the end, we end up with a new board. Or maybe it stayed the same because the field didn't actually change. And this is what I'm making use of here, and maybe this is a bit hacky and not totally robust. I'm basically comparing the new board with the old board to find out if anything changed. And I'm just using this double equals. Now, in JavaScript, this wouldn't work at all, of course, because we would basically construct a new array of arrays, and it would not have the same identity anymore. But I think this does work here. I'm just not sure if it might not be guaranteed. I think if I read the spec correctly, it said something, if something changed, then it definitely needs to get a new identity. If nothing changed actually for a non-mutable type, which the tuples are, so we basically have tuples of tuples, then the identity might stay the same. So the little maybe hack in here.
It'd be interesting to see what's the JavaScript output.
Yeah, I just wanted to know.
Then we definitely know. This is
Where was it? I mean, the alternative would be to basically.
just look for old board equals. This should be.
Yeah, so it uses a special function here.
Can you dive into that?
Yeah.
Oh, yeah, it's a deep equals probably. So that means
Well,
I guess.
deep, I think, if I read it correctly, for immutable stuff at least. So for tuples, it will work. If you use a mutable record, which also exists in Reason, then this would not work.
Wait,
Where?
but are you using mutable here?
No, because a board consists of a tuple of tuples.
Yeah.
So happens to be another reason why tuples are nice here and not using arrays.
Cool. Arrays, but an array by default is also immutable. That would be fine.
If it's immutable, I guess so. I wonder where I read that.
I mean, we're asking tricky questions here.
These are like super advanced questions.
I think I'm not sure if I'm gonna find this here.
I would reckon that if it's like immutable, by default it will have some kind of checksum to verify if it changed, kind of.
Must have been somewhere else.
Yeah, that's for me actually one of the big questions. Why do we have, I mean, OCaml by default has immutable data types. Why did they implement immutable.read? That Facebook, just because it's probably under the hood not using tag trees, or I don't know why yet.
Yeah, I think the way they translate this into JavaScript is through a lot of nested arrays, right? If you, I'm not sure if you see it, but I think a 3 tuple is basically an array, and then inside there's an array. So there might be performance concerns. And if you go to some other native representation in JavaScript with immutable re, maybe that's better.
Yeah. Okay.
Of course, there's different trade-offs, right? If you only just create the structure once and then don't sort of mutate it too much, maybe this is better.
Also, it's an API. I mean, if somebody's used to the native data structures, then learning something new is always an option.
Right.
That's my issue.
Yeah.
Immutable.js for some of the teams I work with, because I was like, by default, they used plain data structures and not immutable.js, and then we had this mess that every second PR was a discussion.
Yeah.
So immutability by default is cool.
So, right. So this is basically to find out if something changed, because if the board changed, then we want to switch the player. Otherwise, the same player keeps playing, right? If they just misclicked on a wrong field, we don't want to go to the next turn right away. Again, this is maybe not totally clean. I mean, it seems you can rely on it, but a different way to implement this would be, of course, to return this from this function, right? So update board would not only return the new board, but also whether it changed, and then update row would do the same, and so on.
I actually just sanitized the input, so I validated if the turn was correct, and if it's correct, then you can be sure there will be a change on the board.
Or that, yep, great idea. Right.
Implementation.
Yeah.
It's a TicTacToe
Yeah.
with 9.
Okay, yeah, just to go over this quickly. Switch player, again, very nice and beautiful. If it's crossed, it's circle, otherwise the other way around. The game state, again, this could have been something that we just always deduce from the board, but in this case, we have it as part of the state. So we need to determine here whether a player has won already, or whether it's whether the board is full. So we have a function has won, and a function rows have empty field, which tells us is there any empty field left on the board. Maybe take a look at this first. This is easier. The rows have an empty field if any of the fields in there, of the 3 tuples of the fields have an empty field. So that's just the usual traversing the board. And has one is a little trickier. It's very explicit. We have a little helper function is full that takes a player and a tuple of 3 field values, and it just checks whether they're all the same. And we can use that more or less as is on the rows, because they are already such 3 tuples. But we also want to check the columns and the diagonals, and for that we simply construct them on the fly. So this is the first column, this is the second one, the third one, and then we have the one diagonal and the other diagonal. And everything ORed together determines whether any player has 3 in a row or column or diagonal.
Why would you, is this auto-formatted, or why?
It is, yeah. That's what
That's weird, yeah.
reformat does.
So yeah, why not do a couple more new lines?
So if somebody's watching.
Yeah, it doesn't
Show a little help.
doesn't really make sense. No? Right. And that's about it. So we've we returned a new state from play turn, and then everything re-renders, and that's the magic. I skipped the restart button. All that does is it uses the updater again, of course, and quite nicely it just returns the initial state that we saved at the beginning of the component and wrapped in this something. Yeah, that's this. I looked at the code. I did mention styling a little bit. So the first thing that you can do, of course, there's a way to do inline styling. I'm not gonna take too much longer with that. But you can see this in this ribbon component, which I didn't go into yet. But there is a way to do inline styling with Reason React, of course. It totally works, and it's probably fine. I just thought I want to play with this a little more and maybe use one of the fancy new CSS in something libraries. And the first thing I wanted to try was styled components, naturally. But that turned out to be a bit tricky for two reasons. Sorry. The one thing is the way that the React API is a bit cumbersome, and we've seen this, with the way you have to define modules, and every React component wants to be a module, and you have to have another auxiliary module that has the render function inside and so on. And I couldn't really make this work in a more dynamic way where I would create these modules on the fly with a function. In the meanwhile, I've read a little more about functors and how you can create functions that take modules and return modules. So maybe this can be made to work, but I'm not sure. The other, and of course with the new API, maybe this will not be a concern anymore anyway. But the other problem is that style components, of course, makes heavy use of tagged template literals in JavaScript. And there is something similar in BuckleScript. The only problem is it only works with pure string values as far as I've seen. So you can splice strings into other strings, but for instance, you can't put functions into sort of a string literal and then do something custom with it, which is what styled components relies on in the end, right? If you want to do something fancy where your styling depends on the props, then you need to pass in, you need to have a function inside your template literal. And so yeah, that's the reason why I abandoned that idea. I mean, you probably could make it work in some other way where you don't use template literals anymore, but that's probably kind of besides the point of styled components, because then you end up with glamour in a sense, and that's what I did in the end. I sort of created bindings for this library, which doesn't use template literals, but just takes in JavaScript, it's just an object that describes the CSS and turns that into class names behind the scenes. I debated between two different APIs for this. One would have been similar to what Reason React does too. With the inline styles here, where basically every CSS property is a labeled argument to a function. Just that these are kind of messy to deal with, especially if you have multiple functions that all take the same labeled arguments. I didn't see a way to declare the labels once and then reuse them. I had to repeat them for every single function, and that gets really messy. So what's happening now in what I released for BS Glamour is when you write your CSS, you basically use the CSS function that's kind of similar to Glamour itself, and then you pass in an array where you just have each CSS property as an item in that array. There can also be selectors and nested selectors and so on. And the only magic that's happening behind the scenes is that each of these functions creates one of these tagged properties. Did we see that? No. Oh, I have that open twice. But here you see it actually. So you know, all the background function does is it takes a string and then returns property, background, and the value. So it's really just a shorthand to make the your style definitions look a little nicer and more familiar. But you could always just spell this out. And another thing that could be done to extend this is to maybe overload these functions, right? Now they just always take strings, but you could make them take numbers or, you know, some fancy color models or whatever. Yep. So that's about styling. And we're basically done with the diving part. Just a few observations again that we came across while working on this. I think it really matters to get the types right. I mean, you can always change things later, and the nice thing is that everything is checked, so refactoring is easy. But I think it's really worth spending some time carefully thinking about the types sooner or later. Order of parameters matters. That's kind of new compared to JavaScript. I mean, of course, you want to create your functions in a sensible way, and you know, you do think about what order the parameters should be in. But since currying is such an important central aspect in Reason and probably any functional language, it makes it even more important to get the order of parameters right. So essentially, and Nick, you had a great talk about that. Essentially, you want to have the most specific parameter last, right? The sort of generic ones, like we saw in the examples where we just passed through the props of the component and each function took the props. That should be the first parameter, because then everyone can just query that and say the props are first and the rest comes later. Right, so that's one thing. The really nice aspect of working with this, and this can probably not be emphasized enough, is that it's just so great to have a great compiler and a type checker, right? What we saw when we wrote this is really that we wrote code and we kept looking at you know, whatever errors came up. We fixed the compile time errors, and in the end we never switched to the browser in the meanwhile. In the end, we switched to the browser and it basically worked. So that was kind of amazing. Then, but when it doesn't work, when it doesn't work, you know right away because the compiler gives you errors. But sometimes these can still be hard to you know, get to the bottom of. So you know, it probably just takes some time to getting used to that. Probably they can also improve some of the error messages in the language. But sometimes it was a bit cryptic what was going on. Like, you know, I was complaining about some variable being used in a way that doesn't really work, but what do you do with that? And yeah, one thing that we saw, sometimes it's useful to just add explicit type declarations to your functions. That can help with that. Another thing that we ran across sometimes was that, you know, things maybe started to fail on the Webpack level because we renamed the module and the old cache or the old JavaScript file that was compiled by BuckleScript was still around, and we were hunting an error in in an application that was not matching our code anymore, basically. So when you run into really weird situations in an app like this, maybe take a step back and look at the Webpack config again, and maybe at the BS config file, and see if everything matches up really. We've already talked about a little bit the Reason React API, which is still a little cumbersome. There's a bit boilerplate there that I think once you get past that, it doesn't really matter anymore. But I guess especially for beginners, it can be a little scary to see too much boilerplate going on there. But that's about to change anyway. What I also encountered is that the documentation, I mean, you can always find answers to everything basically, but you do have to find your way around. And part of the reason, if I say that again, is that there are these multiple layers, of course. So there's reason, which gets sort of translated into OCaml syntax behind the scenes, and then buckle script translates that into JavaScript. And you have to know at least parts of each of these systems to understand some errors that might appear, or also to get certain things done. So again, there's the Reason website, which explains the Reason language itself. Then there's a comparison to OCaml, and something that I found way too late is this converter. Maybe not everyone knows this, but you have this thing in the browser where you can enter either OCaml or Reason and get out the corresponding other thing, and that's particularly useful if you look at the buckle script manual, which tells you about the translation from OCaml or Reason to JavaScript, sort of this bridge. And sometimes you do have to get in touch with this. So when I created the bindings for Glamour, I had to make some native calls into JavaScript. But then the problem is when you read this manual, it's all OCaml. And I mean, maybe I'm missing something trivial, but I don't think you can really switch this to show Reason syntax. But thanks to this tool, it doesn't matter too much anyway. Right. And also, sometimes you get error messages that have OCaml in them, and you might be a bit confused. But then you can just translate it back to Reason. Maybe in the long term, I don't know. Maybe everyone will write OCaml anyway. It's not too different after all, but we'll see. So far, I really like the Reason syntax. There's nothing wrong with that. Yep, and that's what I wanted to say. Thanks.